So this folder for today is going to be covering rational exponents. This is 4.2, okay? We are just going to cover all of this, and we're going to cover all of this, okay? We won't do these problems over here. If you want to start these tonight, you can, but my goal is to get to that, and then we'll get through this. Now, so let's ask the main question of today is this, okay? What does a rational fraction even mean? Oh, sorry, what does rational even mean? Sorry, I'm trying to look at two things at once, and I'm failing spectacularly at it. Well, a rational number is just a number that can be written as a fraction, okay? So, for example, 0.25 can be written as a quarter or 1/4, right? 0.5 can be written as 1/2. 1/3 can be written as 0.333333333333, repeating. Okay, so it's basically just a number that can be written as a fraction. Well, exponents can fall in the same category, specifically fraction exponents. Rational exponents can be written as radicals, which are also called roots. Okay, this is nothing new to you guys. Okay, but what we're talking about here is something that's super important. What I'm about to show you goes beyond anything else you're going to see in terms of mathematics, meaning you're going to see this in pre-calc, calculus, calc 1, calc 2, calc 3, calc 4. It's not going to go away because no one likes to do high in mathematics with radicals. It's a pain in the tuchus. Don't do it. Yes, it is. No. Now, the reason why I say this is because you need to be able to convert fluently between the two forms. Think of it kind of like a subdialect between radical and exponential. Exponential is good for most of the calculations. Radical is good for fine, pretty numbers that you don't want repeating decimals that go on to the 10th place. Nobody likes that. Okay, so you have to pick and choose when you use them. Okay? So, let's talk about how to convert between the two. We've already done this a little bit. I showed you with square roots, but I haven't shown you with other numbers. Today you're going to see it with other numbers. But first, just a minor review. Okay? So first things first. Oh. No, there's a fire. It smells like rubber or something. Now, in terms of that, so we have here is our base number, right? This is where A is going to be here and here. Just going to line that out so you can follow where the color's going. Now, the numerator, aka this part right here, right? The one in blue, is called the exponent. Right? He's there, and he's going to go right here. Okay? That's where he ends up. The index is the denominator of the exponential fraction, which is going to go from here, oops, to here. That's where he ends up, the n, okay? Now, something you may notice is that the letter m is on the outside of the fraction. That is okay for intermediate steps. That's what I was trying to say earlier. Intermediate steps. But it's not proper. We need to get that m inside. So the m actually goes inside the radical, okay? So what you end up with is, oops, m here, and here, and that is the completed form. Okay? Where this right here is the index. Right? Now, there's a note down there that you need to pay attention to. I've said this before, and I'll say it again. This kind of summarizes what I've been saying. Just as we have implied coefficients and exponents for 1, for example, 1x to the 1 is normally written as just x. We also have implied index. If you ever see a radical without a stated index, it is implied to be 2. That's why we call it square root. Okay? Simple as that. So for the first example, we have a to the 1/2, which can be rewritten as a to the second 2 index of 2 square root or radical, sorry, to the first power, which can then be simplified to radical a. Okay? Simple as that. That's the easiest one. You've already done that one technically multiple times. I've even shown you in the previous sections technically, subsections, 4.11 and 4.1.2. See those videos. But here we're now going to start applying it in mass. All right? Again, for this one, same thing. We have a to the first and the third. Darn it, I messed up my 1. Okay, a to the first and the third, which is going to become a radical in there. 3 goes here, and 1 goes up here. So you have 3, and you have 1. Then it converts to the cube root of a. Okay? Last one, a to the first over n, right? So we have, now that's with 3. This can be applied to any number in existence as long as it's in a fraction of an exponent. 3, 5, 7, 100, 10,356, it doesn't matter. So yes, you could take the 10,466th root of a number. Will it give you anything logical? No, but you can at least convert it. Okay? So, and this would be the equation for it. So 1 over n equals n radical a to the first power equals n radical a. Okay? Where pink n goes here and 1 goes upstairs. So I guess to visualize it, you can think of 1 over n, where 1 goes to the exponent on the outside, n becomes a radical, and the fraction becomes a radical, and n becomes the index. Okay? Now, in terms of applying this to numbers, we're not calculating anything here, as it says. We are just converting the expressions. Okay, we're not calculating anything, so don't worry about calculating this. Okay? So you have 49 to the 1/2. So that would be the same thing as 2 radical 49 to the first power, which is then can be simplified to radical 49. Okay? We have radical 12. Remember, there's a 2 here and a 1 out here, which means we have 12 to the 1/2. Okay? These are very, very, very simply straightforward, to be honest, once you get the hang of it. Okay? 6x to the 1/2. Now, here's the thing. With this, there is a big difference between having 6x to the 1/2 and 6x to the 1/2. The difference being one's in parentheses, one is not, meaning that the 1/2 is only applied to the x in this case for this problem. It is not on 6, therefore it's not to the 1/2 power, so it's not radical 6, meaning 6 will not be inside the radical. Okay? In the same vein as, I'll just go to the back side of the packet real quick. For example, you would have 6x to the 1/2 is not equal to 6x to the 1/2 as the same as 6x squared is not equal to 6x squared. Okay, you plug a number in for either of those guys, you're going to get two different numbers. For example, if I put 2 in here, I get 2 squared is 4. 6 times 4 is 24. If I put 2 in here, I get 2 times 6 is 12. 12 squared is 144. Big difference. Don't make that mistake. Okay? Sorry. This is more of just an aside. You don't really need it for your notes. If you want to write it on the page next to it, that's a good idea, because you are going to take this down in there on this side. You say it says glue here. So you might want to just put this on a page next to in your notebook. Okay? All right. Now, right here, so we've got 6. That means that we have technically 6 times x to the 1/2, which becomes 6 times 2 radical x to the first, which becomes 6 radical x is my final answer. Okay? And this holds true going forward for all of these. For example, this one has everything in parentheses, so it's good to go. If it didn't, then the fourth would only apply to the C, guys. Okay? So you're going to have A, B, C to the 4/5. Okay? And that's it. They don't get more complicated than that. All right. 7 times x to the 3/4. Okay, again, because this would be 3/4, so then it's just 7x 3/4. Because this guy is going to convert to 4 goes up top, 3 goes on bottom, x 3/4. Okay, and then 7 just comes down. So that's my answer right there. Okay. And finally, 10 to the 1/2. So it'd be 2 radical 10 to the first, which is the same thing as square root of 10. And that's it. Okay, that at least concludes the first part of the notes for this video.